All right, 1.61. We have information about the normal lead content in blood. It says it's 0.4 part per million. And they give us that with 2 sig figs. Part per million is like a percentage. So let's talk about that real quick. If I had 0.4%, what would that mean? It would mean percent, or per century means per 100. So that would mean for every 100 total units of blood, 0.4 of that was lead. That would be too much lead. Right? You wouldn't survive that. So if you had a percentage, that would mean 0.40 grams of lead is equal to every 100 grams total of blood. That would be a percentage. Per 100 total, you've got 0.4. If it were a percentage. Part per million is the same thing, but instead of percent or per century or per 100, it's per 1 million. So 0.40 parts per million means you've got 0.40 grams of lead per every 1 million, or 10 to the 6th, grams of blood. And that's a relationship. So if they just start the question off by giving us relationships, just write those down so that later when we need to put them into our conversion, we have that sitting there and we can tell what relationships we're going to need to plug in to get our units to convert the way we want. Then it says a value of 0.8 part per million is considered to be dangerous. How many grams of lead are contained in 6? That information about how much is dangerous is just information. It's not relevant to the problem. But the question then is, how many grams of lead are contained in 6 times 10 to the 3rd grams of blood, which is the average amount of blood in an average human body. So then they're asking a question. They're saying, how many grams of lead are contained in 6 times 10 to the 3rd grams of blood? That is what they're asking. So if we have this certain amount of blood, we're going to express that amount instead of in grams of blood, but to use units of grams of lead instead. So the given information we want to convert into grams of lead is that we have 6.0 times 10 to the 3rd grams of blood. This textbook seems to be obsessed with blood a little bit. It's a little bit weird. But when we have the actual question that they're asking, we like to write that down as how many of this quantity would we have if we got it into the unit we're interested in, assuming that we have a same quantity with different units. So this is the relationship we need. We only need one relationship to go from grams of one substance to grams of a different substance or part of that substance. So I would just cancel my grams of blood and get grams of lead using that relationship that was given. The key here, though, is the setup. Recognizing what the question is, what unit are they looking for, what given information do we have, and what relationships do we have to convert the given information into the unit we're looking for. Once it's set up, then it's just a matter of plugging in. So you plug that into your calculator, and you get 0.0024. I'm limited to 2 sig figs here and here, so I can only have 2 sig figs in my answer. So you've got about that much lead in your body on average. Questions about that?
Another way to write that would be 3.4.
Yep. Yeah, you could always put in scientific notation if you prefer. In this case, it's perfectly acceptable to leave it this way because I can't express 2 sig figs, right? The zeros that come to the left of the non-zero digits are never significant, so I can express it to 2 sig figs without putting in scientific notation. Or I could put it in scientific notation. That would also be correct. It also would be expressed with the correct number of sig figs, so either way is okay.